One of the driving factors for a new NASA mission has been the discovery of ice found on the poles of the moon. Inside the poles, temperatures never reach above minus 125 degrees Fahrenheit due to the lack of direct sunlight. These areas are so cold that the water inside gets trapped and can't evaporate. This water can be significant for scientific knowledge, fuel, and support lunar habitation, advancing the upcoming Artemis mission of sending humans back to the moon. To develop solutions for similar future missions, NASA created the Big Idea Challenge, a competition between colleges with an effort for NASA to increase its innovation and capabilities. It has been providing a forum for many young intellectuals to tackle different problems as a college team, one of which was the University of Virginia team called BELL.
My name is Jacob St. Martin. I'm a fourth-year mechanical engineering student, and I was the team leader and mechanical design lead for UVA's Big Idea Challenge team.
To get the rest of the team together, Professor Gupta emailed many students throughout most of the engineering departments, but mainly sought out mechanical, electrical, computer science, and computer engineering students as they were the domains mainly involved in the project. Professor Gupta, with his background in laser processing, had the idea for a project incorporating laser energy as a solution to explore permanently shattered regions on the moon.
Our proposal was mostly just focused around those two basic concepts, that we would use laser energy transfer and that we would try to use some sort of retro-reflective tracking.
Laser energy transfer hasn't been combined and used with an optical tracking system to track moving objects and transfer the energy while an object like a moon rover is in motion. This is one of the technical problems the team overcame to arrive at the solution BELL.
What BELL stands for is the beaming of energy via lasers for lunar exploration. And so what we do is set up an array of solar panels along the rim of the crater that does receive sunlight and convert that sunlight to electrical energy and use that to power a high-powered laser.
Once the proposal got accepted by NASA, they were quick to start development on the final project that was to emerge. The team had to work through unprecedented circumstances. The difficulty of the task at hand only amplified with the emergence of a worldwide pandemic. Despite the challenge they faced due to COVID, it also had its own benefits to their project.
I would say that one of the ways that it worked well is that because our problem is very, very interdisciplinary and requires the integration of a lot of different systems, we were able to work on a lot of those subsystems individually.
However, COVID still took a toll on their progress as a group.
It took a long time for us to be allowed back into labs, and so I think that process of integrating all of our subsystems happened a lot later than it would have ideally.
The team had a lot to consider. Their design had to conform to the design restrictions set by the forum, such as limitations on weight, thermal heat resistance, cost, so they were forced to find sources to buy specific components that fit the BELL design and that would arrive in time.
It was really difficult for us to find some components that would work for our project, actually. Specifically, the galvanometer, which is basically the system that moves mirrors to direct the laser beam. It was really challenging to find one of those that had large enough mirrors for our project, but that could also withstand high temperature and also have a small enough step resolution that it would be useful for tracking out long distances.
Despite the difficulty of finding some components, they were able to source all the materials they needed and move on to preparing for the competition. Unlike previous years in which the team had to be present in person for the competition, due to the pandemic, the team had to prepare a 30-minute detailed presentation that was to be broadcasted live during the online competition.
It was basically preparing that video, making sure that all of our ideas were represented well in it, that it showed the progress of our system, that it introduced the team, gave a good background on the project.
For the competition, the team presented the prepared video presentation, which was live streamed for the NASA judges, NASA workers, the other team, and the general public to watch, which was followed by the question and answer section.
The judges had prepared questions based on both our technical report that we had submitted a few weeks prior and our video that had just been played.
After many months of hard work and dedication, despite facing big challenges, the team's effort finally paid off as they had a successful demonstration reflected by the awards they received.
We ended up winning both the best technical demonstration, which maybe this is biased, but in my opinion, I think that is one of the better awards. other than the primary one, of course. And we won Best Technical Poster.
The results did not only satisfy the team, but also Professor Gupta and the whole UVA community.
I think they did a great job. I was very pleased. Everything went well. We were on time, and it was impressive show by the undergraduate students.
Many of the most important discoveries of the last few centuries have been indirect results of efforts in space exploration. Just all of these challenges that engineers are trying to solve for the purpose of space exploration are also deeply meaningful on Earth as well. Hands down, I'm a significantly better engineer after going through this process. You know, I come from a low-income, first-gen background. A lot of these types of projects or opportunities are not something that I just know about. So I would encourage students to go out and seek these kind of opportunities. Things like this do exist, and it's not that hard to get involved in something like this. You don't have to be approached by a professor. You could go out and seize those opportunities yourself. Don't be daunted by the fact that you don't know anything, because you will eventually.